Starten. Okay, that's running. So, for the second part of our lecture, we want to focus not as much on the low-level stuff, but we want to actually be able to create something that could be used productively. For example, in the lab or in your private experimentation, etc. So one thing that is important for things to be practically useful is a graphical user interface. Doing everything with command line is not very user friendly at all. Also, it is not very suitable for operations where you need some sort, first of all, to see in real time what's happening, or also if you want to do things that have some context to things that have already been done, using a console is rather tedious. So we will want to use a graphical user interface, and for this we need a framework that offers us these abilities. Generally, for Windows alone, one could of course use Microsoft's MFCs, or just use the API that Windows offers natively to create a user interface which has a UI with with a large set of standard control elements that are most useful. But then this would also only work on Windows. So since we want to keep a more how to say it, universal approach and we want to be platform independent, we will be looking into a framework called Qt. It is available for Windows, Mac, and Linux, and in the past it was also available for some more obscure operating systems, which by now are more or less irrelevant. So first of all, we will quickly look into how to install it. So we go on. Is that Qt.io? I guess that's the website. They were sold and bought a couple of times, so the things change, but the main part of the framework always stays under open source license, and this is something that is rather, how to say it, you can rely on it that it will stay like this for the foreseeable future. They have some contract with an which was it? With the KDE Foundation, I think, that they have to make their framework available as open source, and if they fail to do it, then the KDE has automatically the right to make the last framework version open source under not just the LGPL license as it is currently, but under, I think, either the MIT or was it the BSD license. In any case, both of those licenses are substantially more liberal than the LGPL, and that would more or less kill the business model of the Qt group. So they are well incentivized to keep the part of the Qt that they are contractually obligated to keep open source. If you read on the website, they will kind of try always to tell you that, oh, you definitely need to get the paid version, but this is plainly not true. Not just for scientific applications, but even for commercial applications. As long as you do not want to modify parts of the Qt framework itself and then keep those modifications closed source, LGPL is just fine. So yeah, so you can go here and try download, and then there is somewhere a button to go open source, which just means that you are using the free open source version of them. But as said, they download open source here. And then somewhere you get an online installer for the thingy. The online installer requires to create a free account here, but other than that, it's without any restrictions. And I said yeah, and you have these offline packages options also. Let's see what's there. But I think recently they yeah, you get the source codes. You get even installs. Yeah, but you only get the installs for this 5 point something version, not for the newer one. And there's here. Yeah, that's just the source code. So they kind of want to get people as much as they can into their ecosystem. So they move to the online installer. But as said, this is not something that would be mandatory. Once you have downloaded the files, Qt is completely standalone, so you can just zip the folder and move it anywhere, and the LGPL license explicitly allows you to do so. You could even put it on your website for people to download. In fact, to some extent you might feel yourself obliged to put it on on the internet for download, because technically if you make a project that uses LGPL license libraries, then everyone who got your project binaries, even those might be closed source, must be able to at least modify the LGPL parts of the DLLs from Qt, and for them the source code of Qt must be available to those people. And of course you can tell them, yeah, go to the Qt and download the original, or you could have your own copy so that in case Qt goes bankrupt, then that your users still can download those parts for free. So here it would allow us to create an account. I will quickly log this in and then continue further. One moment. Okay, so after logging in and accepting the license conditions, we are at this screen. Then it will get some packages, and ideally we would want Qt 6.5, the latest version of Qt 6.5. I guess in practice any Qt 6 version would be good enough, and for most part Qt 5 is also compatible, so if you have something already installed, don't feel compelled to update. That should work just fine. Okay, that still needs some time. Usually that was faster. Is it doing anything? Well, while this thing is thinking, we can switch to the other virtual machine. The second thing that you will require to use Qt with Visual Studio is this Visual Studio add-in. I have downloaded it here already, but you can also find it on the Visual Studio Marketplace, which is pretty much just a free download store. I don't think there is much paid content there at all. Most of the things are free. The only thing to take care is to get the version that matches your own Visual Studio version. So like there's a version for the Visual Studio 2022 which we are using, and if you have an older version, then you have to take the appropriate older version of the file, and you just can download one of these installers. Quickly see if this is okay. Yeah, the other part was already done, but let's here quickly finish the installation. Yes, we should of course close Visual Studio before we try installing things. I can tell it end task to close it. So what this plugin does, it adds additional build steps to the build pipeline, as well as some custom build tools for Qt resources and forms, which is quite useful. Forms not so much. The resources is a useful thing, although it depends on how you like to create your UI. So the Qt's UI editor allows you to create a UI more or less with drag and dropping elements onto it, which I guess if you want to make something really quickly is more convenient than having to write code and position every element programmatically. So this is up to one's preferences which approach one prefers. I usually try to make every more complex UI by hand, and for very simple dialogues I use the wizard. So it has limitations, so you cannot do everything that you can do in code with this element. But what is also quite nice about it is that you can in fact so each time, so when you have your UI file, which pretty much is just an XML file describing what you have created in this drag and drop tool, which we can take a look into slightly later today. What it just then does is it compiles this to a C++ code. So in principle, you could then just copy this code and then just fine tune it to your needs. So well, that as said, there are many ways. And the first thing you notice when you start Visual Studio, once you have installed the plugin, is that it says that you have to select a Qt version. So let's do that now. the plugin integrates in the general options of Visual Studio. In previous versions of the plugin, it had their own menu element, so now with the 2022 version, it is much more integrated. And what we are looking for, so we go to the Qt directory. In my case, I have one which just says Qt and then another which says the version. On the other VM, we will just install it in the default location, which is one layer less. We select the next again the version, and then we have here different pre-compiled binaries. So Qt 6 is only available in 64-bit for x86, so Intel AMD and ARM 64. It is no longer available for 32-bit x86. You could, of course, in principle, compile your own Qt version from source that would support it, but why bother? If you really need to make something for that would still be 32-bit, you can use Qt 5. They have precompiled binaries, I think, up to Visual Studio 2019 as well. And one thing you can notice here is that I only have here binaries for Visual Studio 2000. Yeah, that's a good point. 2019. I don't think Qt has yet pre-built binaries for Visual Studio 2022. We can quickly check that here. So we don't want to send any anonymous data. We keep the default location. So we want less. We don't need preview versions. Wait. We need to select Visual Studio 2005.3. Yeah, they still have only pre-built binaries, as you see here, for Visual Studio 2019. And one thing I forgot to show you during when we took a look to the installer, we can quickly maybe do this. I didn't think about it, so I showed that during the exercises today morning. So if you need to learn how to install Visual Studio, then just I would recommend you watching the recording from today morning from the exercises, which is on YouTube on the same channel. I will post the lecture here too. So let's quickly fix this small mistake. We go on change, and we will just add the compiler toolchain for Visual Studio 2019, which is this one. And let's see, do we need something else? Yeah, we need some additional components. That was I mean, we could also install the build chain for the build toolchain for 86 for 32-bit, but we theoretically don't need that. That is sorry, that's the new one that we don't want. We just want the 4.1. Wait, is 4.1 the right one? No, we need 4.2. 1.4.2. No, that should be enough. So we will quickly add this to our reference installation, and here we select ARM and x86. Although for your own use case, I would say don't select ARM. You don't need that. You probably don't have any ARM hardware anyways. And you can look on additional libraries. So from these libraries here, a lot of stuff is only under the full GPL, not the lesser GPL license. Although not everything. I think the web engine, WebSockets, those stuff should be under the LGPL license, but other things like keyboard, speech, serial port is, I think, LGPL. So the server is normal GPL. So some of them can only be used if your own project is under the GPL license. The LGPL ones can be used in any project with any license, for the most part. So from those, I would just say we just select serial port, because we might need that if you have any lab experiments where you want to talk to some serial device, then having a serial port is of course particularly useful. Yeah, and I think the rest we can just not install for now. And what here also, debug information is also good to have, because this allows you to, while debugging, then step into the Qt libraries and check if something is failing, where is it failing, why is it failing. That might give you some insight what issue might there be in your code. And here we can check if we need something from there. We could add the OpenSSL. I think the whole rest we don't need. So next, and this will take forever to finish installing, so hence we have the already installed version here. So as said, once you install the framework and once you install the Visual Studio plugin, you need to select to configure this Visual Studio installation, this Qt installation with your Visual Studio. So you find the right architecture for your system which you want to use right now, and then you go to bin directory, and then you can select open. Now you need to select qmake, and then it will enter the directory and give a default name to your installation. And once this is done, we can start creating our first Qt project. So any questions at this point about the framework or the general setup of our development environment for this part of the course? Okay, there doesn't seem there are any questions. So let's quickly, yeah, doesn't matter. We can go here, new project. And now we have this Qt option, and also we have here C++, should be, isn't it? Yeah, there it is, Qt. So we have quite a few new project templates. In principle, of course, you could just start with a completely empty project and fill it up, but it is more convenient to use such project templates. So we go for a Qt widgets application. That's a graphical application with Qt using the Qt widgets UI elements. There is a let's say more modern way of creating UIs in Qt using the QML, so Qt markup language, but that in my opinion has no advantages in your typical professional application. So you can make like dump down applications with nice optically more appealing UIs, but those sort of UIs are wasting a lot of space, so that you cannot create a complete complex sophisticated UI this way. Or if you try, then you would more or less just end up emulating what you would else do with normal Qt widgets. So here for this lecture we'll just stick to the normal Qt widgets. That gives us the ability to really nicely create complex UIs without much complications, let's say. So we select this, then we give it a test, so a name, so let's say Qt UI test, and create. It will then show us another window from the Qt plugin where we can configure a few things. So for once we can select whether we want to start with a debug or with a release build, but let's just select debug build first. Here we can select which Qt modules will be available in our project. As you see, core, UI, and widgets is pre-selected for a widgets project. Core is always required. UI and widgets is only needed if you want to make a widgets application with a QML application. You could have instead, you would just have Qt UI and then Qt QML. Where is that? Somewhere. Or quick widgets. Yeah, we have QML here. But for our application, maybe let's add network. And I think this will be enough. We don't need a serial port right now, so that will be all we need. And then we go next. So then you can configure the name for your main class and the file for it. So for test we leave everything by default. I would recommend checking use precompiled headers, because this improves the compile speed quite significantly. and if you want you can add a standard icon to your project, but that can be easily done later, so we don't do this right now. We just finish and we'll have the project already set up for us with an empty window, and as you see it contains a few files. We have a main CPP which creates an instance of the Qt application. Then we create an instance of our main window and we show it, and then we start the application using a.exec. So this starts the message loop for the UI thread, and it stays in this message loop until the last window closes. The exact behavior can be specified such that you could, for example, configure it such that when you close the main window, even if there are other windows open, the application will terminate as well. But for now we just leave everything at the default. Then we have our main window class, so this Qt UI test. Qt UI test is derived from QMain window, and it has here an object which is called UI, which is in principle representing the machine generated code that can be then created from this forms file. So we'll take a look on this in a second. We just use a predefined function, setup UI, and pass the current object to it. And this file so this object comes from this file, and this file is not included here because it's a machine generated file. When this UI file here gets compiled, it creates this file, and also with the current plugin it is actually updating this file also automatically, so it is not just changed whenever you run the compile step, but it's also changed as soon as you change the UI file. We can of course take a look inside if we want, just by pressing F12 on this, and we see that effectively here we have just C++ code which is setting up the whole UI for us. And if we open this UI file, then it needs to load the design editor, and then we see currently an empty window with a place to add a menu, and whichever control elements we want to add, we can add from the side. I actually prefer to use this in a detached mode, so then it gets an own window. It needs to think, I guess. Oh, it crashed. Let's try again. Okay, something's apparently a bit broken. It doesn't properly detach to an own window. That's a pity. Can we open that somehow? Okay, then it will, I guess, stay attached for now. What we in principle could do, I guess, is to move it into an own. Should be possible to, yeah. So we can put it in their own Visual Studio window. Normally Qt can run in an own process, but for some reason this currently is not working, and we will not be debugging that. So if we want more room, we can just do it like this. So on the left side you have a list of standard widgets. In principle there are ways to add your own custom widgets to this list, but since this makes things even more complicated, this usually is not something anyone would do for just your personal own widgets. If you want to make widgets and then sell them, then sure, do it. But for your own use, what you can simply do is you can place an empty widget here, wherever you want your widget to go, and then in the code replace that widget with your own widget. So this is more reasonable for such smaller projects. And on the right hand side at the top you have the whole UI tree of the window. Currently it's not very complicated, but it can become very complicated once we add more components. And on the bottom here, or rather in the middle here, we have a property editor where we can change different properties of the control elements. But before we do that, let's just go back to our main file and start the project so that we see if everything is set up correctly and it will compile correctly. The SED AFX CPP file is the precompiled header, so as you have seen, it took a bit longer to compile. Also, the name of the file can be changed in the project properties. You could call it just pch or whatever you want, or global header. That is not necessary to keep it stdafx if you don't like that name. Our debugger needs to load some DLLs, which now our project now loads. So when you look on output here, we have a whole list of DLLs that have been loaded. Many of them related to UI operations, although not all. Qt is quite powerful, but it is not a lightweight framework. So it if you want to deploy a project with Qt, you should expect it at least about 15 megabytes in size with just the basic DLLs. And when you want to use more of the more exotic DLLs, then of course it will become bigger and bigger. So this is one thing to keep in mind. But nowadays this is not much storage, so it is a good trade-off for all the conveniences that Qt offers. Okay, it's still downloading debug symbols. So what it is downloading here are basically PDB files which are associated with the DLLs from a Microsoft server, and those files contain informations like function names for even the internal not exported symbols of a DLL. So if something crashes in a part of Windows, you can at least see how the function was called in which it crashed, which other function called it. So while you don't have the source codes, obviously, you can at least have some idea what might have went wrong based on the function names. And here we have our first window. As we see, it doesn't do much. It's just an empty window. So now we can stop it and then open our editor and add something. So let's say we could add some text edit. Play text edit, and we could add a few buttons. 1, 2, 3. Okay, and now as you see, they are just somewhere, so this is not quite useful. Usually what we would want from our UI is to be somewhat responsive to being resized and so on. So we can just select the main windows and specify a layout. In this case we selected grid layout. You can also which means you can align the elements in a grid. You could also select a more simple layout, like just vertical layout or horizontal layout, so it would be elements next to each other and only next to each other, or on the top of each other. But obviously you can use a grid layout to achieve the same as well, so the other two layouts are not so useful. There is also a special layout for forms if you want to create those. And in principle you could also create your own more complex layout if you would want to, but I don't think there really is a reason for doing so. Obviously we can make individual control elements take up more than one cell in our grid, and we can use spacers like these ones to define the resize behavior. So if we want to have all the buttons on one side, then we can do that. Okay, so now let's just quickly save it and run it again. Zack. And voila, we have our first window. So now let's add some function to it. So first of all, let's give this some better names. This we just called text. This one will be, or maybe let's call it differently, text edit, and this one we'll call btn new. Then we also need to change the caption for the button. Well, we don't need to, but it is convenient if the button says what it's doing. If it would be, if every button is just called button and without telling you what it does, it's quite difficult. And let's make a save button. If you haven't noticed by now, we are making a very simple text editor, just to demonstrate how to use the Qt UI and how to interact with it. Save, okay. So we save it, we can close that. then we go to our main window here, and after our UI we can set up the connections between signal and slots. And signal and slots is a concept which in Qt is very central to how you are supposed to interact with the different components, and how you are supposed to connect those different components of the framework with each other. The idea is that you can call a function which is called a signal, and then this call goes into the inner workings of Qt, and then every other object which slot was connected with that signal using a connect function will be invoked, and the parameters which you pass to your signal will be then invoked on that slot. Functions which act as slots can also be invoked just directly like any normal function, but in addition to this, they can be invoked through Qt's internal meta object system, which is quite useful, especially if you are writing a multi-threaded application, as the way this meta object system is designed allows you to queue function calls, such that you can have a thread which an object does not belong to, and then from this thread you can just invoke a slot on a object that belongs to another thread, and the system will just cache all the parameters that you want to pass, wait for the message loop of the other thread to execute everything until it reaches our entry, and then it executes our function call in the other thread. And depending how you have set up your call, your previous thread may either be blocking until the other thread finishes its task. This way you can get a return value back, or you can say it to just queue it and continue, so then it will be executed asynchronously in the other thread. This is quite a useful mechanism. As such, in normal C you don't have such mechanisms, so if you want to have something that behaves this way, then as Qt did, you would need to write your own whole message handling system. But in Qt you have all these mechanisms already made available to you. And it is also very useful when even working within one thread, because then you still can connect objects to each other which have otherwise no awareness of each other. They just need to have matching signals and slots. And this is also quite a powerful mechanism. Of course, it comes with some not insignificant overhead. So you would not want to do it with any function call. If you can just do a normal function call, that's of course preferable. But it allows you for much more flexibility. So here we will first start with creating a couple slots for our 3 buttons. On new, they're extra trivial. They don't have even a argument on open and on save. Oops. Of course, how you call them is up to you. The only thing that is important to define something as a slot is that you need not to just define something as public, but you need to define this public slot. And the slot as such is just defined in Qt first as qslot, which is then somewhere else. At some point you go to a point where it's just defined as nothing, and that's the whole way how Qt is able to work with C++ and create the appearance of extending the language without really extending it. You have also here, for example, this queueObject. This actually evaluates to something. It adds quite a few different members onto our class, which are needed by this Qt meta object. So this needs always to be included, and any class that is supposed to use signals and slots not just needs to have this included, but it also needs to be derived in the end from queueObject. So here we derive from QMainWindow, but if we continue the chain of inheritance, at some point we see that we derive from queueObject. Okay. And I said here, this slots is for the C++ compiler. In the end, it's just nothing. While for the Qt meta object compiler, which runs on the header files, it indicates that it should create some special source code for these slots, which then will be put in another machine generated file like this one, just with a different name. And in the end, the way this works is that the compiler compiles this machine generated code and is able to this way extend the normal C functionality. Qt quite excessively does that, in fact. So here we have defined our 3 slots. We need to create bodies for them, of course. Without bodies, they will not be able to do anything, and the compilation will fail. Okay, and of course, an important thing to know is to know which signals and slots all these objects have. So it's always good to check out Qt's all classes documentation. As you see here, there's more or less the list of every single class that is available in Qt, which is a huge lot. But for now, we are interested in the Q push button. And we see that the Q push button inherits Q abstract button, and actually, as such, it only has a slot show menu, but it doesn't have even describe which signals it might have here. So we need to go to the parent Q abstract button, and here we see that we have a few signals. So we have clicked, and the button, since a button, so an abstract button is everything that is more or less clickable. So a normal push button is an abstract button, but also, for example, a radio button, so this round thing which you can select just one out of many, is a radio button, or a normal checkbox is also derived from an abstract button. And in principle, you can make a normal push button toggleable, so that if you push it, it will look like it's optically be indicated like it remains pressed. This is why the abstract button implementation actually has presets for is checkable and check state, and why when it is clicked, then it would tell you what's the new state of the button. Then we have also a signal which is pressed when you push down your mouse, one when you release it, and another one when the state is changed, which might seem a bit redundant with the clicked, but you can change the state of a button also programmatically, while to click it you should mechanically click it. So let's see what this is derived from. Okay, that's enough. So let's go for pressed. And let's now do our first slot connection. So we just write connect, and connect is a function which is defined on QObject. So first of all, here of course it's defined on our own object as well. But if you would want to make a connection from a static function from somewhere, then you could just write Q connect, and as you see, it is still available because it is defined as a static function. Maybe not this one, but one of the other ones should be inline static. Yeah, this one. So there are apparently different versions. There is some non-static connect version as well, but the most universal ones are the static ones. There is also a disconnect function if you would want to remove a slot connection, but for simplicity we just go with connect. And you also notice here that there are quite a few different versions. So the old Qt system, like Qt 4 and the first versions of Qt 5, they were quite simple. They only took a QObject as center, and then a signal to indicate to which signal to make the connection to. With newer features introduced in C++ 17 and so on, Qt6 has actually expanded on this connect mechanism to also allow other ways of connecting between functions. Most useful part is that it allows you now to use a lambda function as a slot, so that this is actually quite nice. But for the first test, we will just stay with the old school terminology, old school syntax, and much later we will then take a look into the newer variations of connect. So we need to first tell it what is the sender. So ui.txtedit, not txtedit, bitine button new is the sender. Then we say we want a slot. In the slot we need to write in principle just the name of the function with the type and without the name. So this example here is not yet ideal. We'll look later for an example where this is demonstrated in a better way, and then we can specify the receiver. As you see here, it could be just a function with the newer Qt version. We can also provide a context in the function, and if we click far enough, then we are at the standard version where we just provide the current object, and then we can provide the method. So it will be a slot that was on a new. And an interesting thing is that you actually can connect signals with other signals. So if you have, for example, an object which represents something and has some sub-object, and then you want something that uses your external object to be able to react to a signal emitted from an internal part of your object, you don't need to like define your own slot which then would just emit a signal, but you can directly connect this one signal to another signal. So a signal can trigger a signal, which can trigger a signal, which at some point down the connection chain will then trigger a slot. So that is quite a nice optional option. So let's now go for the other three. New, open, on, and save. On save. Yep. So we can put some breakpoints here and see whether it works. So when we press any of the buttons, we should reach the appropriate slot here in the source code, the appropriate breakpoint. Let's see, new. It's not working. Well, it complains push button doesn't have pressed. Did I mistype that? Should have it. It's also the right version. Wait, what did we do wrong? Oh, shit. The first, of course, must be signal. I'm saying signal and writing slot. That's that, of course, cannot work. Also, you noticed here in this very much scripted and intentional mistake that if you connect something with something that you cannot connect to, Qt will produce you a error log line to indicate that you did here something invalid. So this is actually quite useful. Now it should work. Zack. Let's quickly test the last one as well. Zack. As you see, we end up in the right slot, and let's quickly click on the last one. And now if we go to the call stack, we can also see from where we in the end came. So this code here is again machine generated code by this Qt meta object compiler, and as you see, it's it is quite a lot, and in special cases that might not necessarily compile. So there are scenarios where you are using types in your class which then might be missing there. So in principle you can go to properties, meta object compiler, force include, and if you run into such errors, you can then force include, make it include some of your own headers which you require for your own types for everything to compile. So if you run out problems with the meta object compiler, here is a bunch of settings that can help you with that. Most important is this force include, which allows you to specify which additional includes this generated header file, or in this case this generated source file should have. Okay, so well, new will not do much. It will just delete the content of the edit control. Takes the edit. Most Qt classes that store anything have a clear option which just deletes whatever is in them, be that a text edit or a list or a string or whatever. You can always clear it with clear. Yeah, and we will then later look to other things. So for open, you might want to open the file. So again, we can quickly look to the documentation. There is a special dialog. Oops, that was once too much. Why can I press the forward button from here? That's annoying. Oh wait, there is no forward button. Doesn't Edge have a forward button? How stupid is that? I should install Firefox in this VM. Edge sucks. File dialog, this one. And QFileDialog is again a class which we will need to include. You can, by the way, see here in which package it's contained. So it's in the widgets package, like most graphical thingies. We could actually include it in our precompiled header. That would just, of course, make the precompiled header compile longer, but it is a good practice to include all the Qt stuff in the precompiled header because they are quite convoluted, and in the end, your build time will be much faster if you include it there. Okay, we need to build the precompiled header again. Let's quickly compile that. Yeah, as you see, it takes really a long time to compile this Qt stuff. Okay. Oh wait, it's why is it complaining here? We have not included that. Did I started typing something? No. Wait. Oh, I pressed Ctrl C or something. Failed. Okay, but then yeah, we want to open text, so now we should be able to get the intelligence. Yeah. Open. No, not open. What was it? Get open file name. That's the right one. Okay, so we can pass a widget if we want the window to have to always stay on top of the parent. So yes, we want that. Then we can specify a caption. And in Qt, there is a mechanism to help with UI translation. Basically, you can put all the strings you want to use in this tr macro, and then what it will do is it will automatically extract all the strings marked this way and provide you a nice UI to translate them. And as well, this macro will invoke a function that allows you to have a text substitution such that all the strings that you have in your program will be automatically substituted by the right other language in production use. So this is quite nice. So here we say just let's say test open file. Then we can provide a default directory, which we don't. Then we can provide a file filter, which we don't. Then we can provide other things which we all don't. And this thing just returns us a string with the file name. And of course, if we press cancel, then the string will be null. Also, I think there is one of the options. Is there? No, there isn't. So for some of the windows, you have a boolean that you can query whether the user explicitly pressed cancel or not. But here apparently not. So if this is empty, then return. Okay, and now we will want to read that file. So qfile file. Apparently qfile has been already included by one of the headers that we already have, so we don't need to include it explicitly. But if we would want, we can. We just specify the file name in the constructor, and then we can open it. In this case, qfile for reading, read only. And we can have a if, so we can check whether that was successful or not. So if it was not successful, then we just fail. Let's do it this way. If we fail on open, then we just return. And ideally, we should call close once we're done. But since that's an object in the current scope on the stack, it will be distracted automatically, and Qt invokes close on the destruction of a file anyway. So in this particular case, it is obsolete, but it is good practice. For example, if we would have a loop or something, well, then it would also be destroyed on the closing of the scope. You could, for example, reuse the file by setting it another file name and then opening it again. That would be a use case where you actually need to close. You need to close it before you can set a new file name. Otherwise it would of course be a bit problematic. And here, before we close the file, after we opened it, we can read it. So there is either the normal read function, which allows you to do a few things. So one version of the function allows you to just specify a length, and you get a qbyte array object with the data. And the other option is that you can specify a buffer you want the data to be copied into, and then as well a maximum length. In which case it only returns the amount of bytes that it has read. And there is also if we don't know how large the file is, we could of course first of all get just by size and query it. But there is also the read all option, which just allows us to read whatever is left in the file. So when we open a file, the pointer for the file points at the first byte in the file, and when we are reading from it, this pointer is moved each time. So if we make read and read 10 characters and then call another read for another 10 characters, it will not read from the beginning, it will read from where we stopped reading the last time until we reach the end of the file, at which point it will fail the read operation. There are of course functions which allows us to change this, like seek. They allow us to move the pointer to where we want it. And this read all, what it will do, it will from the current position read all up until the end of the file. So if we obviously invoke read all at the very beginning, then we get just everything. It returns as a qbyte array again, so we can save this into a file, into a variable qbyte array. Let's call it data. Qbyte array data. And now we want to set something on our into our text edit. So UI text edit set text. No, set plain text. Set plain text. And as you see, this one's a qstring, not a qbyte array. First of all, usually this should just accept it because there is a built-in conversion, but we could also explicitly convert it. Qstring. And as you might also notice, there are quite a few conversions. So we have from Latin 1, that would be just from normal ASCII, from UTF-8, which is just UTF-8 encoded text, which is the most common type of encoding that you will encounter. And you could also from other types like VString, that would be a Unicode 16-byte character, 16-bit character type. UTF-16 that is similar. UTF-8 we already had that. Yeah, so yeah, there are, I said, a few options to convert it if you want. But if you just have normal ASCII text or file names or stuff like that, then you could just go with the default conversion. I'm actually not sure which one is the default, but I would assume it will just take the Latin one because that's a one-to-one conversion. It's the cheapest one and has no decoding. So we can run our program now again just to see whether that works, and then we'll quickly continue to the next thing to be demonstrated. Okay, so we can open something. It's thinking. As you see, it's loading some symbols, since the new dialog will need a few more Windows DLLs, which on this VM we haven't used yet, so it needs to download the debug symbols for those. In principle, we could have disabled the debug symbol download. That would make things faster, but it's in my experience quite a nice thing to see if there is anything. So if something breaks where it broke. Also, it only downloads those symbols the first time it encounters a new DLL. So later during the lecture we will not have that many delays because of symbol loading. In practical use on your own computer, you generally the way this works is that if you install some Windows update or something like that, this might in fact change some DLLs, and then it will need to re-download for those DLLs these symbols as well, but it probably will not be like all of them. Okay, we are done, and we could actually open one of our files, or we could go maybe here and open one of the machine generated source files. It's still loading some symbols. Where they are? For example, this one. and voila, we have loaded the file. So, and if we press new, it just empties it out. The save is quite trivial. It works just analogously to open, just that you need to use the get open file name, and of course not read all, but just write, and then not read only, but write either read write or just write on, or write only. The difference is read write allows you to read and write from the file, and also if you are writing the file, it will just overwrite the content up to the length that you provided. If you provided more data than the file has, then it will extend the file size. But if you just write a small amount of data to the file, then the rest of the file will still stay there. So this might not be what you want when saving a text file. So here the write only option is better, because write only, when you open the file for writing, it will also truncate it to 0, so that once you're done writing your data, then you are sure that there will be no other things in the file. So this actually will be the first homework assignment. UI takes the input. Get save file name. Okay. And another thing I can show you is here we can add a check, so that we don't like lose the data. So if we have already edited something, to plain text punct is empty. So if is not empty, then message box question is again title after but this time we can also provide some actual text for the message box, so this will be much longer text. So for example, we want to overwrite, no, need to overwrite clear. We want to clear the edit content, question mark, comma. Box, which one we want? Yes, no. We want one button that says yes and the other button that says no. And we can provide up to 3 buttons for the message box, but only the first one is mandatory. And we can also say that we want no to be default. Default. So the pre-selected button will be the no button, and then we of course need to check what the user has selected. So if message box is ungleich yes, so it will just return the numeric value of the button which has been pressed. So if it's not yes, then we just return. And of course we have not any functionality here that it won't ask if we just saved. So that would be good to have. So let's add it here. Okay, and what we would also need here would be an ability to know whether the content was changed since it was last saved. So for this, we can again go here to our too much to this and qplain text edit and inspect which signals we have. We have, for example, text changed. So we can add here some more guidance. Oops, I didn't copy it. We should also provide the class name. Right, yo. So you can use this one, which you just connect on that UI text edit object, very similarly to this, also with no arguments, I think. Text change, no arguments. Yeah, so that would be the first assignment for this project. So since we now very quickly went through quite a big chunk of Qt, I dare to say by now you all can create UIs in Qt, at least knows the basics how to do it. So I wanted to ask if there are any questions, if you want any of those mechanics to be explained in more detail. Okay, if there are no questions, then we could continue with our small project. Oh wait, did we open this twice? When we wanted to open it, apparently it opened. It just took forever to open. Let's see if it now will work faster. Well, it takes forever. It for some reason takes forever. But it started the Qt Designer. Why does it take so long? That's puzzling. At some point it will open again. Okay. So I think the next thing which we would like to take a look into would be probably this signal and slot system in more detail, and maybe the ways to manually invoke signals and slots. So for this we will create a new project. Now it opened. We keep the other project open, so just create a new instance of Visual Studio. Okay, the whole RAM is already used up. How much did I give the... Okay, 8. I should give more RAM to the virtual machine. 8 gigabytes is apparently just barely enough for one instance of Visual Studio. So that's... well, that's how it is. Visual Studio is quite a memory-hungry application. Okay, so we have C++, we have this. We can type here... and we see here we have a Qt application console type of project available as well. So the other one was UI, so this one will be just Qt test without UI in the name. And since it's a console application, it will I think ask us for much less things. So of course here it only needs the Qt core module, it doesn't need the other ones. And on the next window it will, I think, only ask us whether to use precompiled header, if at all. It might also just not ask us at all, I don't remember right now. What's the default behavior? We are just far too out of memory. Let's just see if we can change this in real time. I think with the new VMware versions that actually works. Now the whole thing froze. Okay, here we are. So let's just go to 16. It's quite nice to be able to add memory in real time. You cannot remove it. You need to reboot the virtual machine if you want to reduce the amount of memory. But adding new memory apparently works now without stopping the operating system. So it's what it basically does here is like it puts it into kind of standby, and then it resumes it from standby and tells Windows, hey, you have much more memory now. I think the application here got a bit confused about this. It does not. Is it not installed there? Wait. What did I install? Nope. Nope. It's installed where it should be. Now we see we have much more memory free. Half of it is now free, but somehow this is still busy. I would say that's the FOFO effect. It should be working much nicer than... Okay, the system is kind of busy all the time. That is not good. I think I will just reboot the machine. I think there is something screwed up. I don't also know when I rebooted. That was the wrong button. When I rebooted it the last time, I just always suspend it, and at some point Windows just wants a reboot. But it was the wrong button. I have pressed suspend. That was a waste of time. Of course, now it takes twice as long because we have twice the amount of memory to save to disk. And we store from... I think after it already restarted, we could just hard reset the whole thing. Yep. Okay, so let's... You'll also have to see whether it created some files or if it didn't create any files. There was a document and another document. So was Qt. It created some for the some files, so we delete the folder and then just we don't remember we had any unchanged changes, but why not? This just reopens the existing solution, and then we just open a new Visual Studio again for the create new project. Console. Qt test. Zack, great. Yeah, now it's much more responsive. I bet now the starting here of the editor outside will also work properly. Yeah, it's much faster, so the reboot helped significantly. Right, so we have here our Qt test. So in this case, you see that it creates not a Q application, but a Q core application. You see the difference. The Q application actually is just derived from Q core application. Well, first it's derived from QGUI application, which then is derived from Q core application, which in turn is derived from nothing. That's how deep that goes. Okay, so we have here our QCore application, and then first thing we will want to do is we want to start a few threads. So let's create a few classes for those. So normally, when you're just using C++, then a thread, a single thread, to start a thread, you just need the function create a begin thread, and provided a function which then will be executed as the entry point of the thread. And that's it. With Qt, the whole thing is made a bit more complicated. Of course, you could just create a thread using the platform-specific APIs and then provide the static function. But if you want to be platform independent, then you will need to use the Qt way of creating threads, which means that you need, for every thread, you need to derive an own class from the QThread class, and then have set class implement the right virtual function. So let's call it myThread1. We don't want this to be a name, and we say as base class QThread public. Okay. So here we have our thread. As mentioned before, if we want to use signals and slot, we need to define QObject. And later we need to define public for our constructor. And in our main function here, we can include our thread. myThread1. myThread1, and then we just start it. Before we start the message loop, as said, we will not exit the message loop until the application gets terminated. In this case, it will terminate when we close the console window. Okay, and we have here our thread, and then now, of course, what do we implement for the thread? First of all, we would want some constructor. That is always good to have. So it's my thread here. Suck. And already one thing to notice about these things is that pretty much anything that is derived from QObject has the option to get a parent object specified. So it is good practice to keep this ability with our own implementation. And the reason for this is that Qt keeps a what's the English word for that? Abhängigkeits dependency list for all the objects. So you have one object which you create at some point which will not have a parent, but if you create other objects which should be valid within the context of the first object, then you can set the other object as parent, and then you don't need to care for destruction of this object, of these objects, because when you destroy the parent object, all child objects will be destroyed as well automatically. So this is quite a convenient way to be able to use pointers and have Qt take care of some of the memory management for you automatically. There is as well a second level of belonging to, so an object can not just have a parent object, but all the objects have to belong to some Qt thread as well, and the thread they belong to will define in which thread's context the individual slots will be executed. So the way this works is, if you have an object that belongs to a thread, and then you would, for example, decide that you will never call any function on this object from other threads than the main thread, then you don't need to write the object itself in a way that would be thread safe. So you can save on synchronization. This can have advantages, and it makes your work slightly more convenient. And then, if you would have to invoke a function from another thread, as already mentioned earlier, you can use this meta object system of Qt to invoke that function. The only main thing to keep in mind when using this methodology is that the thread on which on which belonging to objects you want to invoke functions using this meta object system must have a message loop running. So we have already seen in the case of the Q application that on the application object there was this exec function which starts the message loop for the main application, or basically just starts the message loop for the main thread. And on every other thread you have also this exec function which starts its own message loop. But whether you actually start it or not depends on how you implement your thread object. So in the simplest way, as we have done here, so we just have the constructor, we don't have anything else, it will in fact start a message loop for this thread. So we can so we could use this. One thing to know, however, is that this, how to say it, the thread itself will still be so the object, so the thread object which we create here, the Q thread object, is supposed to not belong to itself. So it should belong to the main thread of the application or another thread in the application, and only objects created within the thread will then belong to this thread internally. In principle, you could make an object belong to itself. You can move objects between threads using move to thread, but this complicates things. So what we, for example, might want here is we would want to somehow call a function on this newly created thread, and one way how we can one way how we could do it is we can make the thread here implement the run function. Oops. Didn't void run. So this function has their own body actually, but the default implementation of run just invokes the message loop. Was it? Yeah. Okay. We don't see the source of that. Not yet. We can, but when we go to it, we can then see that it just invokes exec. But having our own implementation of run, what we can do is we can create some objects here. So and they will belong to the new thread. And then once we are done with everything, then we can just call the run implementation on of the thread object. So let's quickly run this. We have the thread, we start the thread, that's all we need. Needs some time to compile. And then once we are here, we see that we are in a new thread. You can also inspect the process in the task manager of our own choosing. Threads. Actually, we see that there are quite more threads than we expect. So in addition to the main thread and our Qt thread, there are 2 more threads. These are usually created by Windows, I think starting with Windows 8, to load DLLs during process startup asynchronously, and they will be terminated once they haven't been needed for a short while. So only those 2 are relevant. I think we need to exit this not to conflict with anything. Right, and here we can also now step into okay, it asks us where the sources are, so let's quickly tell it. Qt 5.9 source Qt base, I think. Yep. As soon as it recognizes the path, it will run it, and here, as you can see, the default implementation of thread run just calls exec. So we could as well have here written exec, and then that would be that. So this could be done this way as well. Okay, but what we wanted to also show is this signal and slot mechanism, so we will need to create a few more objects. For our testing, my class 1 from QObject public. So let's create here an own class. We want to allow it as well to specify a parent. And on this class we will specify a slot. Slots. My slot 1, and let's give it int and let's give it a number and a text. Yeah. We can include this QDebug header, which allows us to nicely print things to the debug console. So in this case, we can just print the number and the argument we have gotten, and we can put a breakpoint here to see from where this will be called. So let's go to our main object and create here our main class. So we'll create an object of type our class, and then we have this thread, and then let's say that we will we need somehow to communicate the class to our thread if we want to invoke a thread on our a slot on our class. So let's maybe add it as a public variable, since it's just for testing. So that's the wrong header. This one. So this is public, so we can set it from our main function. That of course is not something that we would do normally, because that's not ideal, but just for the demonstration to not complicate things too much, we just set a pointer. And then in our thread 1, so first of all we can give a signal to it. Void my signal 1. It was my signal. I mean, the name doesn't really matter, but we need to have the same arguments. Oops. My signal 1. Okay, then we go to our run function. Okay, we can also specify here some internal slot. Let's call it on init. Oops, void. Or yeah. So this one we will need to create a body for. And in this on init we just emit what was it? My slot. Sorry, my signal 1 with 1, 2, 3. Test. Okay, now we need a way to invoke it. So for example, here we could use QTimer. We need to include QTimer. I think there is for pretty much any Qt class also a header of the same name. So single shot. this comma, wait, what was the interval? So let's say 10 milliseconds. Yeah, then receiver is this, and slot is on init. So this call here will schedule the invocation of onTimer in 10 milliseconds from now, and but this will only happen once the run here starts running the event loop. And then from inside our thread we will emit a signal, and then of course we need a second object which will then receive the signal. My class, wait, now we already have it, that's this one. So now we just need to connect those. So we can do it at any point as long as it's done before it's invoked. So we want to connect the center will be wait, that's not correct. This since this needs to live in a new object, so we need to add a second object first. Because as I said earlier, the thread itself does not live in its own thread. The thread lives in the previous thread. So if we want to have an object that exists inside that thread, we need to create it within it. So public my class 2, okay. Right here. So again we need to can copy this. We just change this to 2, and we can copy that. Just change it to 2. Right here. So we need to go here. Right here, and those thingies need to go on our in there. Signals and slot, yep, and then of course from the thread this one goes away as well. That is moved to class 2. My signal 1, that's okay. Right here, and then go here. So we need to do a bit more housekeeping. That will not be that trivial. So we will need to have a pointer on class 2 as well, because that will be our own object which will live in the current thread. Oh, we need to include that as well, that we have forgotten also. Include my class 1 and my class 2. Okay, so here we create a new object already in this thread, so it automatically belongs to our new thread 1. Then we and then here this one needs to use this as well. Wait, is that no? That should be enough. It's complaining here because this one is not done, and we need to do the connection. So we connect the sender is this. Signal 1 reference with the reason why we need to specify the argument list is because we can have in principle multiple signals or slots which just differ in which arguments they take. So we need to specify those for this connect mechanism to know. When we would be using the newer version as available with Qt6, then I can show this later, then we could do it a slightly different way and don't need to have remember the proper argument list. Right, and we want to connect this with class 1, which is a receiver slot my slot, and the my slot has just the same argument list. And we close this. Okay. Good. So we can put a breakpoint here, a breakpoint there, and then a breakpoint here we have as well. So what we expect is we can expect to have 2 threads, and then The first thread will invoke, so that our worker thread will invoke the onInit, which will emit a signal, which will then make our first thread, our main thread here, to print this to the console. So let's try if it works. Where we have our console. It's a good start. Now we have here our run, and we see here that we are in the NTDL run user thread start. So we are in the, and then just here the Qt thread private start function. So we are in our thread. We are not in the main thread. And if we now press play, then again we see we are still in the same thread. So my thread 1 run, and then run again, and then exec, obviously, and then we have a lot of Qt internal stuff happening with regard to handling the message loop. But at some point here we have our signal, and if we press here, that didn't work. No such slot. I probably mistyped something again. Thread 1 connect signal. My slot 1 was the name, not my slot. So as you see, it's quite helpful since it doesn't produce exceptions, which would crash your application, which might be actually beneficial with regard to bringing your attention to it. At least it provides log lines if something fails. So here, as you see now, we have reached slot 1, and we see here that again we are here in this thread start, but instead of being in a Qt thread, we are in this main CRT startup function, which then calls our main here, and then we have a lot of Qt stuff again with regard to the message loop. So it's this Q core application exec, which we started here, and then the function is invoked within our own context. And this is quite a nice way to communicate between threads. There are other ways, there are other mechanisms. So as said, we don't necessarily need a signal. We can invoke a slot directly. So we could try this next. So let's create a new slot, my class 1, slot 2. Maybe we should print here, which function we are printing from. My slot 2. We put a breakpoint here as well. Then we need to go to header and create 2. Right, and this one we will change. We'll make it have a return value of type QString. And what do we want to return? Test. Let's return test. Okay. QString. That should be fine. Why is it complaining? Yeah, oh wait, that was the wrong file. Yeah. It might be better to use more more different names. Just adding 1, 2, and 3 is quite prone to selecting the wrong file, but now it's fine. Okay, so we go to our thread 1. We go to our onInit. Maybe we should rename it. onInit is not the best name. Let's call it doRun. That sounds much better. The name is more or less meaningless. We just need to be consistent about it. And also here we could move this to our constructor here to keep things together. We just need to include the timer. So as you see in this project, we don't have the precompiled header. So the result is that we need to include everything every time. That could be improved later on. So we have here our timer. We can make the delay maybe a bit longer. Then it will call our doRun, and here instead of emitting signal, this time we want to use the other method. So Q meta object invoke method. We need to specify which function, and that okay wait let's do it differently. Since here we need to have actually the pointer to our class, so here instead we will just comment this out and that, and do this directly from our thread run function. So we have our class 1 as the receiver, then slot, we say we want my slot 2. My slot 2, it doesn't care for the return value in the specification. Was it QArch? There is a macro which we need to use here. I just don't remember what it was. I thought it was QArch, but no, it was QArch. It just needed to think before it started recognizing it. So first we say the type, then we say a value. So again, let's say 456, and then the second one again QArch, const q string reference, comma, and as text, let's call it text. Okay, and strichpunkt. So this should now, from the other thread, effectively invoke our slot 2. We haven't yet did anything with regard to return values. So let's quickly check whether this will work. I hope it will not complain that we have a return value without querying it. It might be that it might not like it, but I think it should ignore that, or not. Wait, there is a typo somewhere. Class 1 my slot, that should be fine. Class 1 my slot 2. Okay, it might want us to specify that it has a return argument, so I think it was QRet. We can just look where this was defined. QReturnArg, that was the name. QString, and we need a variable where to receive the value. I think. Okay, now it should not complain about not having a place to return the return parameter. So if you would have been calling the first one, that didn't work either. Wait, in const string. Wait, that was, sorry, this one works slightly differently. It just wants us to specify the name without the argument list. It builds the argument list it needs automatically from the arguments that you pass to it. So it's not necessarily very consistent with itself. Almost. Okay, so it is still complaining that about the return value that it does not know what to do with. So we need to specify that the connection must be blocking. What was it called? Qt blocking Qt connection. Now it should be fine. And first we are here, and you see that we are in our main thread. We have our arguments. We should turn off hex display to see the 5456, and then we'll be able to return test, and then in again our worker thread we got the return value. So the way this worked was the thread queued the operation on the message queue of the other thread and set a flag that it wants to be resumed once the other thread processed the queued operation and was waiting until the other thread finished. Of course, if you would try to call if the two threads would try to call each other in a blocking way, then it would result in a deadlock. So there are things to be careful with. And we can invoke the slot 1 the same way, just that here we just don't give the return value. So now we should end up in both. It's slot 1, that's the right name, yeah. My class 1, my class 1, my class 2, my class 1, yeah. So now we will end up in both of them. One will return a return value, the other will not. Okay, so again we are in the first one, and the other one in principle could already be running further. So actually we should have set a second breakpoint. Let's quickly do it, because this one, as said, is non-blocking. So when we expect that we probably will arrive at this breakpoint. Yeah, we arrived here. This has been queued, but it hasn't done yet anything. And since it was so fast, then the other thread hasn't woken up yet. So when we continue, then we will execute both of them. And once we executed the second one, we can continue from this blocking connection. You can specify this connection type also when connecting with this connect command. So, but usually what is done is it picks the auto connect option. So if the threads are, if the objects, both objects, the sender and the receiver, are in the same thread, it will use a direct connect option, which bypasses most of this mechanism. I could demonstrate this next. And then in which case, actually I don't need to make a test case for that. I can show it based on the other project here. So since here everything is in the main thread, it will use a direct connection. So if we just put a breakpoint, for example, here onto the new slot. What is it complaining? Apparently we have not saved this. It's missing the code I wrote earlier. Well, then we just remove that. I guess you can rewrite the message box from the recording if you want to do the optional part of the homework assignment. So creating a small message box is not much of a problem. So here we see that everything happens in one thread, and at some point okay, we need to where will that be? That will be, I found it. Okay, so we have here a mouse press event, which then goes in the okay, this is still in. So we have a function called a virtual function called mouse press event, which is defined on a widget. So if you press it, the event will always be dispatched to this function, and then the QAbstract_button class has overloaded this function with an own implementation. The implementation here then does its stuff, and at some point decides to emit pressed. So we go to emit pressed. We need this file. We will not have this because we only have the real source code, but we don't have the intermediately generated machine generated code. So this file we don't have. The next file, but we have the next file. So actually the interesting thing I cannot show you because we are missing this particular temporary file. So if you want, let me know if you want to see how this direct connect works, then I can set up a test case. Otherwise we just continue with this. But the general idea is that the whole message loop doesn't get involved. It just looks up the function by name in the meta object and then just calls it by the function pointer. So such a direct connect is much more performant than if you would be using a queued or blocking queued connection. And as I mentioned earlier, this auto connect mechanism will pick the right type of connection for your use case. I think it only picks direct or queued. It doesn't pick blocked queued. So if you want blocking, then you need to specify it manually. And in principle, what you could do is if you would manually specify that you want a direct connection, then an emit from another thread will call the function in itself on your object. So if you would specify a direct connect manually, then you would need your implementation of the slot be implemented such that it would have some synchronization objects properly synchronizing your internals of your object across multiple thread accesses. Okay, so that much to this. So we already know how to create threads and objects. I can demonstrate one more thing here with regard to this thingy. So if we comment this out for a second and go back to our initial mechanism, what we can do is we could move this object to the other thread, although then I guess this will not work as expected. So we'll leave this in here, and those two we will create here directly within our thread. So are we creating it in the main thread? We are doing the connection in the main thread. No, first we move it. So we use we need to move it to the right thread. This. So we can in the constructor of our thread create objects, and since they belong now to the main thread, which is the thread in which the constructor of our new to be created thread is executed, we can use the move to thread function on them, and then we can move them to ourselves, at which point they will belong to this. And I think that if we call this after the move, then it will even work. So this way we don't actually even need to re-implement run. We could completely comment out run thread 1 run. As we remember, it just internally calls exec anyways. Right here. So as you see, it can be simplified quite a bit. Let's just quickly check if this works. So do we have all the breakpoints needed? Class 2 has a breakpoint here, and it will then just invoke on class 1 here our slot 1. So let's run it. It's compiling. It complained about something. Sure, that is a small mistake. We didn't have yet our class 1 set. So here let's maybe improve on that architecture wise. Instead of setting it in a quite unelegant way, we will just pass it to the constructor. mythread1 constructor zack. Then in main we will need to... We cannot do this anymore to complain as it now does about both issues. So first of all, here that now we try to assign something to a protected variable, and secondly that we are missing a mandatory argument for the constructor. So we have fixed that now. And now when we run it, it should work without complaining. But it still complains with... So as you see, I have included the headers only here and not in the header itself. So we need to tell it that this will be a class object, because otherwise it might be a struct or anything else. It doesn't know what it is. This is quite a nice method because you can have pointers to objects in your header file which you have not included in the header file itself. So this allows you to more elegantly structure your code. One more mistake. My class, yes, the names were without the P. So I'm a bit inconsistent here with the naming scheme myself, but that's fine. Naming schemes are just, well, they are voluntary. So we have our signal again here inside our worker thread, and we have the invocation of our slot inside the main thread. Really nice, and it works. And when we close the application and the whole thing, so if we close the console, then the main message loop terminates. And if we want to terminate the thread, we actually can do that as well. So well, there are a few things which we can do with a thread. First of all, we can wait on it, which is not recommended because then we will never start our own message loop. So this is not a good idea. But we could do it if we would want to. And we can also just quit the thread. So this can be called from outside of the thread and it will terminate its message loop. So let's create a second thread, which job will be to kill the first thread. Actually terminate. Kill is like ungraceful termination. And just properly terminate is to terminate it gracefully. So not... so generally you would not want to kill threads in your process because all the resources which the threads have allocated internally, if the thread is just killed, will not be freed. What you want to do is you want to have some signaling mechanism that you can use to signal the thread. Okay, now it's time for terminate. To terminate, the thread will terminate its message loop, release its resources, and then it will quit. And you just wait for the thread to quit. You can specify a timeout for this wait function so that you see, okay, the thread didn't quit within, I don't know, 10 seconds, and normally it should terminate instantly. So something's royally screwed. So you can then either just ignore it, or you could then decide to kill the thread. So it's a not good situation in any case. So see my thread 2 from Q from Q thread. Again, we don't want to see the file name. Okay. Okay, so let's go to our main function here and start the second thread. We don't tell it, well actually we need to tell it something. We will give it a pointer to the first thread so that it knows on which it should call in the termination. We'll just include everything here just for good measure. Oh, I have a typo. That's not how you write thread. The first thread has a typo that we will need to fix later on. We can although fix already. Wait, why is this complaining? This needs to be 2. Okay. My thread 2. My thread 2. My thread 1 and do we have this somewhere here? No, we don't. As said, it is good practice to provide always the option to specify the parent object. You might have noticed we haven't yet had time to try the parent mechanism out ourselves. So we probably should try it out next, since we will now be able to terminate a thread. And look how this thing works. That will be a good thing. Okay, and now the problem, we need another class that will live without our thread too. Wait, we already have a my class too. I will call it my class 0 and rotate all the names. That will be a bit confusing at first, but then it will be easier. So we just want everything that class 1 does to be done by class. Oops, didn't copy. By class 0. Class 1. Class 0. Let's see where we use list. So here my class 0, 0, 0. Oops, we need to include the my class 0. Right here, and everything that my class 2 does, we will move to class 1. Okay, and class 2 will not do anything for now. It also does not need a slot, but we will leave it the run slot so that we can make it do something once it's ready to do something. Class 2. And this way, the idea is that thread 1, and we should fix the thread naming as well. Rename thread. This is of course one of the more annoying aspects of C++, that even if you rename the file, it will not rename. Oops. It will not rename the things for you as, and this should be class 0, class 0, class 1, class 1, class 0, class 0. Right here. In some other languages, this is organized a bit better so that you can so that things are automatically renamed. You can refactor them, so to say, much easier. Null 1 1. I will need to include here the null as well. My class 1. We don't need my class 2 in turn, and here C is missing. Okay, what else are we missing? My class. Let's see if it compiles. It's not yet done, but it will. We might have missed something with the renaming. Okay, there is some issue here. What is this complaining about? Class 1, class 1, class 1, co-object. Class 1. Class 1, that should be fine. My class 1, object parent, my class 1. Object parent do run. It says this thing is already defined. Already defined? Is it already defined? No, it's not. My class 1H. My class 1H. Here we are missing the closing brackets. Losing closing brackets usually can result in very odd error messages. If you lose it at the right spot. Right, we forgot here to rename one include. Okay, of course here this right yeah. So now we can implement thread 2, but thread 2 we will want to have a pointer on this thread 2, and we will want to also have a pointer on semi-class 2 stern and my thread 2 zack is new not next new this one we assign. So we create an object, my class 2 is not yet included. Then it should be fine. My thread 2 was it? My thread 1, that should be fine. My thread 2, what's it complaining about? This we didn't forget. My thread 2 is written properly. My thread 2 probably some very stupid mistake again. So we have class my thread 1 object. Let's just run build again and see what that gives us a better error message. Just underscoring the thing. But it is the same object class my thread 1. Yes, I see the bug. Here we had the typo still in the class name of this variable. Zack. Okay, so that compiled, and now we go to thread 1. We can copy some of the function logic. So again, we will want to move this time class 2 to the other thread. We will want to invoke on class 2. No, we don't need a connect here. We want just to invoke to run on the thing, and we of course need to include the timer. And this time we give it much more time because we want the run operation to be done later. So our class 2, but the class 2 is yet unaware of class 1. So what's best to do? We could just pass it there as an argument. That's probably the most elegant option. Class 2 will take an argument. Class 1, zack. Class 2. That's the wrong. Didn't I copy that before? I thought I did. My thread 1. Right here. So if we go to thread 2 here, actually we don't even need to keep a reference on my thread 1. It's enough if class 2 does this for us. Right here, and this thing is then run. And of course we could do it differently. Could use the invoke method, but we'll try that later. For now we just leave it this way. Do on timer right here, and so we go to class 2, and on our need this. On timer here, we'll just invoke, oh no, we need to get the implementation. Thread 2, zack, hello. Wait, was it thread? Sure, we need thread 1, not thread 2, that was the wrong one. Quit. And now we go back to thread 1. And we will uncomment our run, because we would like to keep it overloaded. But we will not do any of those things. We'll just write here qdebug, qdebug, which we need to include again. One thread 1 started, thread 1 stopped. Thread 1 started, thread 1 stopped, and then we will put a breakpoint here and go to thread 2 and put to our class 2 and put a breakpoint here. Okay, it complained about something. My thread 1 my thread 1 in line 15, let's quickly fix that. My thread 1 in line 15, class 1, my class 1, sure, one of them should be one class 0 signal, and we want this my slot that was on 0. Yeah, renaming class, especially if we pick names which oops, which already exist, is a recipe for disaster, so I would recommend not doing it. Or if you need to, then use the global search and replace function of Visual Studio, and there you can do it in a, let's say, smart way by first replacing the one name to some placeholder and then replacing it back to the new name. So you see, okay, let's again run it. So we don't have any complaints here. We just got our thread start notification. Now we are in the other thread after 1 second and want to call the quit, which makes this thread quit, and then it will print thread stopped. So this is how it works. Of course, the other thread could then also call quit on itself. If we would want to wait, no, we need to get the thread. So there are quite a few there are quite a few functions defined on the queue object. One of them is it was the thread or was it current thread? I think it was just thread, which allows us to access the thread we just belong to directly. So if we do this, then we will terminate both threads. So we can inspect this in our Task Explorer tool and see that both threads, once we did this, have been terminated. The only thread remaining is the main thread from our threads. There might be some thread created by the... Okay, so there are these two threads created by the DLL load, and for whatever reason you have a thread that is odd. Play sound, we have no idea why this was created. So there is quite a lot of things going on in a Windows process which kind of happens behind the stages. But I have no idea why that would want to invoke play sound v. There is a option to make a beep. Exit with code 0. Wait, let's run it again. But at this point it should not complaint about anything. Let's try again. Well, for whatever reason this is still loaded. Also, it is possible that the text shown here is incorrect. So if the symbols are for some reason not properly matching, then this is something that can happen as well. That you think they are in some function, and in reality are somewhere else. Especially with symbols created for release binaries like the Windows DLLs. In this case, this Win Multimedia DLL. You cannot always rely on those being correct. Okay, so since we have a thread being terminated, we can now investigate this thread, this object creation and destruction behavior. So first of all, we can go to our both classes and give them a destructor. One here and one there. Oops, that looks like a recipe for disaster. Yes, this should be true. Okay. Let's quickly run it and see if Qt will destroy any objects on its own once the threads terminate. And as you see, it did not. It killed the threads, but the objects kind of have been left around. So this is not what we want. So what we can do here, first of all, to get rid of this class 2 object, we could invoke this delete later, which will dispose of our object as soon as it is possible. And I think that should work even if we will it work if we call quit on our own thread? It might not. If we call quit on our own thread, it might actually not work. But we can just let our own thread keep running. Let's try what it does. Sometimes it's better to test something than to make an assumption and then find out that the assumption was wrong. So we are here, yeah, and now it invokes the destructor before it creates the thread. So this delete later just puts on the message queue the instruction to destroy the object at the nearest opportunity. And now we also need a way to destroy our class 1 created on thread 1. Class 1, what was it? Thread 1. So here we have done some changes to invoke things this way, but what we could do is, again, we could comment this out, then have our create, well, actually we can leave it where it is. The whole idea is that here after run we can implement explicit delete instructions for whatever objects we might want to delete. So when the event loop terminates, then it will just hard delete whatever objects we know that are left and need to be disposed of. So let's run that. And now we will reach both destructors. So as you see, that there is some utility in this run, in overloading this run function. Okay, here you see we call the delete directly from our run, or let's say manually from our run. But there is, I think, another trick we could also try. We can look quickly into the documentation, there. So let's just go to the queue thread. Now we only have the threads. That's annoying. It doesn't bring us to the definition of it. So let's reopen quickly our crashed edge. Go back to our queue. And as you see, there are so many classes, there is not really a way to remember all of them and all of their functions, so this documentation is really very helpful. And we see on signal, and you see here there is the signal finished. So what we can also do is we can trigger events which will happen once the thread says it is finished. So this might be useful if you want from somewhere outside of your thread control do something once a given thread which might run for a long time terminates. You can use this with this finish. Also, you have a signal started which is invoked when the when the thread gets started. So this can be quite useful there as well. Okay, so what else to show you? We could of course just create a few more classes and show how this parent system works. I think this is a good thing to show. Let's call it see my class 3 Q object large O. So this class we will then just on one of them, doesn't matter which one, class 1 or class 2. Yeah, let's use it on class 2. So my class 3 my class 3 asterisk. So we go to our constructor, new and this as parent. It complains because we haven't defined the constructor yet. So let's go to my class 3 and define the constructor. I need to copy it again. Yeah. Somehow the history of this clipboard is not deep enough. And we also add a destructor so that we can track when the object will be destroyed with a breakpoint. And now we will see that as soon as object, where did we put it in? I think 2. My class 2 gets destroyed, it will automatically. Right, we need to include that as well, otherwise we cannot construct it. So as soon as here the destructor for class 2 will be called, then it will also, so afterwards, so first we end up in this breakpoint, and next we will end up in the other breakpoint. So first of all, here we have our delete, then we have class 1. Class 1 we have destroyed because of quitting the event loop of thread 1. Now we are in the destructor of class 2. And then we enter first internally the destructor of QObject here, which then deletes all the child objects, including our class 3. So this way, you, for example, if you want to do something in a thread, you can create one object. Even in principle, we didn't even need to create a own thread class. We could have, because as you see here, thread 2 actually doesn't do anything, because this code here could just as well be executed afterwards. The only thing that we might need here is that we no, we actually really don't need thread 2 in the way we have designed the code right now. My class 2. Yeah, well, it keeps this, but it doesn't really do anything with it. Yeah. So yeah, we could have even saved this. So we would just need to create an object, which we create an object. We use then move to thread to move it to the new instance of our thread, and then we call a slot on it. And we don't need to use this timer single shot. We could have called the slot using the QMeta object invoke method function as well. Also, I'm seeing that we are running out of time, so I think it's time to quit for today. I will upload the lecture to YouTube. I will upload both test projects to YouTube as well, and create a homework assignment for the small homework. Where was that? That we have here in to complete. Oh wait, haha! The second part of this is also missing. We have lost quite a bit apparently during the forceful reset. That maybe wasn't the best idea. So. Okay. Right. So I will make an assignment for this, and like with the lecture part 1 last year, you have 2 weeks time, or rather 2 lectures time. So if there is like a week where there is a holiday, then it just extends the deadline by a week, and if there are 2 weeks with 2 holidays in a row, then it extends it by 2 weeks more. So yeah, that's how it works. The idea is that during the first lecture after the assignment was assigned, you have the opportunity to ask any questions if you have troubles with the assignment, and then it is only due on the next assignment after, on the next lecture after you had the opportunity to ask about something. Are there any questions? No questions? Okay, then let's finish for the day. I will stop the recording.